at some quadratic functions and different ways to solve them. When we talk about quadratic functions, they actually have many different solutions, honestly. Depending on how it looks is usually going to be how you know what to do. And I will have a piece of paper with all the different forms. Right now, we're going to look at factoring and the square root property. If you read 3, 4, and 5, I'm going to do videos for completing the square, which is very important, the quadratic formula, and then substitution. So for this video, what we're going to do is a factoring example and 3 square root property examples. Okay, so for the factoring example, if you have ax squared plus bx plus c set equal to 0, you can do the AC method. And I'm going to go ahead and just throw this into the factors because we've done the AC method a couple of times and there are videos over the AC method. And of course, you can leave a comment or do whatever you want as far as like asking me to do another one if you need me to. There's another way that you can also factor. And we know that because my variable is squared, I'm going to have 2 factors. And what I mean by that are these parentheses with the terms inside of them, we're going to call those factors. That's why this method is called factoring, because you get it into factors, right? Well, technically what we're doing is kind of like a backwards FOIL in a way. I know that if I have x here and x here, and I was to go through here and FOIL this, x times x would give me that x squared, right? So what you do is go ahead and like separate your x squared into 2 x's, and then for the last parts in each of your factors, we need to figure out what term goes there. Well, if I look at my c, it's a 12. So I need 2 numbers that multiply to give me 12 and add to give me 8. 2 and 6. 2 times 6 is 12, and 2 plus 6 is 8. And those would both be positive. If you do it this way and it does make sense to you, awesome. I would totally prefer this way over the AC method if I don't have to do the AC method. Just make sure that you pay attention to your signs. If the 12 was negative, if the 8 was negative, like just make sure that you pay attention to signs because your terms inside of your factors will be affected by that sign, okay? So now that we have x plus 2 and x plus 6 set equal to 0, we literally would set both of those factors equal to 0 and solve. And so I would end up getting x equals negative 2, and I would get x equals negative 6. So this would actually be the answer to factoring that trinomial because it was set equal to 0, which means you're actually going to solve what the value of x is. Okay, so let's do these 3 problems for the square root property. Let's do this first one, which is 3x squared and negative 15 equals 0. So the square root property just basically states that if something is being squared, what we can do is take the square root of it because they're inverses of each other. So the first thing you want to do is isolate any terms that have x squared, and that's only going to be my 3x squared. And what I mean by isolate is let's move our 15. So we have 3x squared equals 15. Okay, so now this is actually in the form that I need it in to be able to do the last step to isolate my x squared. I notice it's being multiplied by 3, so you do the inverse, which is division, and I get x squared equals 5. Okay, now this is where we're actually going to apply the square root property. Because my x is being squared, I know for a fact that taking the square root of something being squared, they're inverses. Whatever you do to one side, you have to do to the other, being sure that you add your plus minus sign. Okay, now on the left-hand side, those cancel. That's what we wanted. Now I've only solved for just x, which is the goal. And if you look on the right-hand side, you cannot take the value of the square root of 5. I mean, you end up getting a decimal, and that would be improper. That would be wrong. You would not get the points on an exam, on your homework. It would tell you that, it is equal, but you're actually going to leave it in the square root, in the radicand, because it can't actually be evaluated in that manner. Okay, so x equals plus minus the square root of 5. That is the answer for that one. Okay, let's do this other one right here. We have 9x squared and a positive 25 equals 0. Okay, same first step, isolate whatever has our variable. And then we're not done yet because I noticed that my x squared is being multiplied by 9. So what I do is I'm going to do the opposite of multiplication, right? The inverse, and that is division. Those cannot be reduced. They have no common factors. Now I notice that my x is being squared and I need to just solve for x. So what you do is we take the inverse of multiplication. Why did I say multiplication? The inverse of it being squared, which is taking the square root. And what you do to one side, you have to do to the other, being sure to add your plus or minus. Okay, so there is an actual rule when we deal with roots that states, okay, so here we know it cancels, right? We have our x equals. You have a large radicand over a fraction. What you do is you actually take the square root of the top number and you take the square root of the bottom number individually. I'm going to go down. Now, if we evaluate this, we get x equals plus or minus. Okay, very important. There is a negative sign underneath the square root, and you actually can't take the square root of a negative number because it's imaginary. And what I mean by that is that negative sign needs to come out, and it actually becomes your imaginary unit, which is I. So, and then if you notice, what we would have left under the square root is just the square root of 25. Well, I know for a fact the square root of 25 is 5. So what I have in my numerator would be 5i, or just 5. You can keep the I next to it. Either is fine. But this might be a little bit easier to understand that it was like pulled out. It's separate, right? It couldn't be underneath the square root. Now, if you do the square root of 9, you get 3. So that is going to be the answer for that problem. Now, if we do our last example, what we had was in parentheses, we have x minus 2, that's all being squared, equals 6. Okay, so I said that if something is being squared, you have the ability to take the square root of it because those are inverses of each other. So I'm literally going to do just that. And what you do to one side, you have to make sure you do to the other. What it does on the left-hand side is it's the inverse of it being squared, so it cancels it. And the only thing you're left with is just the binomial that was underneath the radicand. And then you have equals plus or minus the square root of 6. Now I still haven't really solved for my x because I have that negative 2. So I need to move that. And I get x equals 2 plus or minus the square root of 6. On our square root of 5 answer and our 2 plus the square root of 6 answer, I want to do something just as a little side note example. Here, we couldn't actually evaluate the square root of 5 or the square root of 6. I want you to make sure that you understand that if you have, I don't know, 28 underneath the square root, you're right. That's not a perfect square, correct? But we can use the fundamental theorem of arithmetic, which just states that all numbers can be written as a product of prime numbers. Okay, basically what I just said there was that we have the ability to write this number as prime numbers, and then we could actually use our root to look to see if anything can come out of that radicand. So I know, another word for it is prime factorization. I know that if I do 28 divided by 2, I get 14. 14 divided by 2 is 7. So this is telling me that 28 is the same thing as 2 squared times 7, right? So I'm looking for something that has, because that's a 2 right there, right? I'm looking for groups of that size so that they can come out of the radicand. And I notice that I have 2 2s. That means that A2 can come out. You just need one representative, okay? So now I have 2 square roots of that 7 stays underneath the radicand. So again, in my examples that we just did, if you took the prime factorization of 6, you get 2 and 3. There's no groups of size 2. So it wouldn't work. Same thing with 5. It wouldn't work. But if you do have a number that is larger than 5 and 6, go ahead and do prime factorization just to see, can something come out. Okay? So that's it for this video. Make sure y'all ask me questions if you have them, okay? Thanks. Bye.